Hi everyone, welcome back to Statistics and Data Analysis. Today we want to introduce you regression analysis, one of the most useful statistical techniques. So in this video I'm going to give you an introduction and then gradually we will tell you first what's the concept of least square approximation, the basic idea of regression, and then talk about how to validate a constructed model and some advanced issues. So let's start. In many cases, when we are given a few variables, we will try to find their correlation. For example, suppose I have a set of simple data with 12 houses. For each house, I have its size and its price, or the selling price. So I am wondering that whether the size can somehow determine the price, or what's the relationship between each other, because I am intuitively, if a house is larger, then basically its price should become higher. So when we are interested in the correlation, obviously we may want to calculate correlation coefficient when we have two variables. And if the two variables are both quantitative variables, then we can just apply the formula for correlation coefficient. And in this example, it's about 0.729. So that means when we have houses, and we can use the size to be a good predictor for price. Like if I will get a house whose size is 100 meters squares, this information can help us predict the price, because we know they are related, and here quite related. But if we are really going to do the prediction problem, then we are interested in finding a formula so that if we input 100, we get a predicted price. How do we get that? Well, that's one question. One more step further is that we probably want to find the correlation or relationship among more than two variables. For example, in this house problem, not just size may affect price. The number of bedrooms is sometimes also an important issue. So some houses, they have different number of bedrooms and they have different prices. So maybe the number of bedrooms also affect the price. Maybe no, maybe yes, we don't know. So that means we want to summarize the correlation among more than two variables. That's one thing we don't know how to do, because we can compute their pairwise correlation coefficient. But if we want to use one number to summarize the relationship between three variables, we don't know how to do that. Or if we want to still do the prediction, if we want to use size and the number of bedrooms to predict price, then again we want a formula, and we don't know how to do that, right? In general, we may have a lot of variables, and we may want to find their relationships. We will want to ask that given a few variables, is it possible for us to predict other variables? That's the idea. That's the topic that we want to introduce today. So for the given questions, regression is the solution. There are all kinds of problems, all kinds of solutions. Here, regression is one of the most widely adapted tools in statistics for that kind of problems. Relationships among multiple variables, and how to use some variables to predict other variables. So, regression discovers the following things. If we have a set of variables, then which variables affect a given variable? And what's the impact on the target? So if I give you a lot of variables, you are going to use regression to select some of them to be the most useful parts for predicting a given variable. Just like in the previous example, when you have house, when you have size and number of bedrooms, regression is going to tell you which variable is more important or both of them are important and how they affect the target. In general, we will predict or estimate one variable that we call it a dependent variable. And to do that, we're going to utilize our knowledge on multiple independent variables. Okay? So, independent variables are those potential factors that may affect the outcome, the realization of the dependent variable. And the dependent variable is the thing that we are interested in, that we want to predict. It's the outcome. Independent variables are sometimes called explanatory variables, and the dependent variable is called the response variable. So, explanatory means I want to use these independent variables to explain why the dependent variable is so high or so low. So they are used to do explanations. The dependent variable is a response to the values of the independent variables. That's why it is called a response variable. So in our house example, the price is the dependent variable. Okay? And the number of rooms, number of bedrooms, and the size, they are the independent variables. As another example, suppose we want to predict the number of arrival customers for tomorrow. Okay, this is something that we don't know. So we are interested in understanding the number of arrival customers. Then some independent variables or some variables that may help us to explain or to predict is that what's the weather tomorrow, whether tomorrow is a holiday, whether there is a promotion or not, what's the price for that product, etc. Okay, so that's just one example. So today, and actually for the remaining lectures of this semester, we will talk about regression analysis. There are actually multiple types of regression analysis. So you can say regression is actually a family of models or a family of methods. There are a lot of them. So first, we may use the number of independent variables to categorize the regression models. If we are doing a simple regression, that means we have only one independent variable. On the other hand, if we have more than one independent variables, then we have multiple regression. Okay, multiple regression. Or our independent variables may be quantitative or qualitative. Or our independent variables may be quantitative or qualitative. In today's lecture, we will tell you how to include quantitative independent variables. Okay, so make sure that you can remind yourself that everything we talk about today are with quantitative variables. Qualitative variables can also be chosen to be independent variables. In the next lecture, we will tell you how to do that. We need some special treatments for them to work. Okay, so that's something to be introduced later. We will only talk about something the so-called ordinary regression, where the dependent variable is a quantitative variable. Okay, so again, it's also possible to have a qualitative dependent variable. That's possible. But if we want to do that, we need some advanced techniques, which is somewhat quite different from the ordinary regression we introduced in this lecture. So basically in this course, we will only talk about ordinary regression. In this series of lectures, we will only talk about ordinary regression. Okay? So that means your dependent variable must be quantitative. So maybe later you will see some problems For all those problems, you will only deal with quantitative dependent variables, okay? But independent variables may be quantitative or qualitative. It's just that for qualitative independent variables, you need some special ways to deal with them. That's going to be introduced in the next lecture. Okay, so starting from the next video, we're going to start our introduction to regression model building. Thank you.